Hi again, everyone. Welcome back to our course in college algebra. We are continuing our discussion of polynomial functions. So in this video, we're going to put together the three key parts of a polynomial. So if I give you a polynomial function and I start to ask you questions about it, this is the stuff you need to figure out. You need to understand what the end behavior is. We talked about that in our previous video. If you know the degree and the lead coefficient, then you can figure out the end behavior. Another key component is knowing the zeros, which is equivalent to knowing the factors, which is equivalent to knowing the x-intercepts. So if you know any one of the three items in this little diagram, you automatically know the other two. So if I gave you a graph and you could see the x-intercepts of the polynomial, that means you know the zeros of the polynomial, which means you know the factors. If I gave you a polynomial and you found the factors, then you know the zeros, which means you know the x-intercepts. And the third thing is knowing whether the graph crosses the x-axis or just touches the x-axis at the various x-intercepts. So let's start with an example. We'll sketch the graph of this polynomial function, f of x equals x power 3 plus x squared minus 6x. So right away, we can tell that is a degree 3 polynomial with lead coefficient 1. All right. So I know what the end behavior is going to wind up looking like. It's going to be up here like this and down here like this. Remember, we had those four partial graphs in the last video. Now, I can't tell more without knowing a little bit of extra info. In particular, I need to know the zeros or the factors or the x-intercepts. Now this polynomial, I notice every term has an x. Factor out an x. So then I'll have an x, and then inside the parentheses, x power 2 plus x minus 6. I'm looking at this quadratic. I'm trying to factor that. I look for two numbers that multiply together to give me -6, so not a lot of options there. They have to have opposite signs, right? So the factors have to look like this. An x and an x, because first times first would give me x squared. One of these guys should be plus, the other one should be minus. That's the only way to get a negative product, is to have one of each sign. Okay, so the combinations that multiply to 6, 1 and 6 is always a possibility, but if I put a 1 here and a -6, that'll give me a -5. That's not what I want. If I put a 6 here and a -1 here, that'll give me a +5. Doesn't help. Turns out what I need is a 3 and a 2. Okay, so a little bit of process of elimination there. Okay, so that tells me something here. I'm going to have x-intercepts at -3, 0, and +2. So my x-intercepts are -3, 0, and +2. Notice, each of the factors corresponds to an x-intercept, which is where the function is 0. Gives an output of 0, okay? So, -3 comma 0, where's that coming from? Well, this factor, if x is equal to -3, this factor is 0. And it doesn't matter what these other guys are, because they'd be multiplied by 0. And anything multiplied by 0 vanishes. Okay, so -3 is a 0, so is +2. If I put in x equals +2, this factor would be 0. And don't forget this one. If I put in x equals 0, this factor is 0. So the function gives a y value of 0 in these three places. Okay, we're putting this together with the end behavior. I'm seeing, okay, I got to do something like this. Okay? So, a fairly accurate graph, getting the gist of everything. Notice I didn't spend a ton of time figuring out the height on this guy. When you take calculus, you will learn how to figure out what the high points and the low points are. You'll find out an easy way to do it. For right now, let's just worry, okay, your intercepts, well, you either got to come down and then up, okay? Or go through. Now, how do you tell whether you're going through? You look at the multiplicity of each zero. So let me write some things out here. My zeros are -3, 0, +2. The multiplicity of each of the zeros was 1. That's the number of times the factor appears in the expanded version. Okay? So they're all multiplicity 1, so the graph is going to cross at all those zeros. So the key thing here is the multiplicity odd or is it even? If the multiplicity is odd, the graph will cross the x-axis at the corresponding x-intercept. If the multiplicity is even, the graph will touch the x-axis but not cross. Okay, let's do another example. And we'll mix things up a little bit. We'll change up some multiplicities. Okay, f of x equals x power 4 plus 6, x power 3 plus 9, x power 2. Okay, so right away we can tell the degree and the lead coefficient. The degree is 4, lead coefficient 1. So I know my end behavior. We're thinking back to those partial graphs. Okay, so factor out an x squared. You get x squared out there and in here. X squared plus 6x to the first plus 9. And that factors. We're looking for two numbers that multiply together to give me 9, but when I add them up, I get 6. 3 and 3 do the job. So that factors into x plus 3 times x plus 3, or x plus 3 squared for short. All right, so let's get to graphing. By looking at each of the factors and setting that factor equal to 0, I figure out the x-intercepts, or the zeros of the function. If I take this factor, it's x, and I set that equal to 0, I get x equals 0. Right there, that's a 0, that's an x-intercept. If I take x plus 3 and set that equal to 0, if x plus 3 equals 0, that must mean x is -3. That's an x-intercept. And now I also know the end behavior of my graph. It's looking like this. Okay, you see it right there. Now, notice the factor associated with this 0 is squared. Okay, that has multiplicity 2. That means the graph should just touch the x-axis without crossing. Same thing here. The 0 at -3 comes from this factor. It comes from the factor x plus 3. And that also has multiplicity 2. So the graph should just touch here as well. So my graph is going to look like this. Come down, touch without crossing, that means I gotta come back up, okay? But I know somewhere around here I gotta turn around, because I got another 0. And I touch without crossing, come back up. Okay? So I get this kind of W shape to my graph. Okay, so once you know the key components to look for in a polynomial, sketching the graphs is kind of a breeze. Okay? Spot the degree and the lead coefficient, which is easy. Figure out the factors, which tells you where the x-intercepts are. And then look at the powers on the various factors, and that'll tell you whether your graph should cross the x-axis or just touch without crossing. Put that together with the end behavior, and you have everything you need. Okay? We'll look at some additional examples where we work problems from my math lab for this type of stuff as well.